Welcome participants. Now we are going to move in lecture number 4. Today the topic I have chosen is shrinkage performance of the fabric. In reality, whenever you create any knit fabric on the machine, you will observe that once you take out the fabric from the machine, it will try to shrink. And shrinkage is extremely important from garmenting point of view, because whenever we want to create garment for a perfect body, we need to create size of the fabric, and if the fabric shrinks in certain way, it will be extremely difficult for the designer to knit the fabric size. So, it is very important that you should understand how the fabric shrinks along course direction and waist direction, and what is the role of stitches in deciding the shrinkage performance of the fabrics. So, in this particular lecture, I am going to first introduce you what is fabric shrinkage, what do you mean by that, and what are the influences of different stitches like loop, tuck and float on the fabric shrinkage. So, on the machine, whenever you make fabric, you will observe that after you take out the fabric from the machine and if you place it in a table, the fabric will relax. Because of that, fabric will try to shrink in all directions. So, this is the shrinkage performance of the fabric, and shrinkage is extremely important. For example, let us suppose if you want to create 2 meter length of the fabric, you need to run the machine for certain time, you have to create certain number of courses. So, when you are making the fabric on the machine, you created, let us suppose 200 courses of the fabric, and once you take out the fabric, you will observe that 30% of the length has been lost. So, in that case, it is very much important that you should have some kind of understanding for achieving a particular length and width of the fabric, how many needles you should be selecting on the machines and how many courses you should run on the machine to achieve particular dimensions of the fabric. So, that is why shrinkage become extremely important. So, in this particular lecture, we are going to observe these shrinkage performance of the fabric. So, first let us try to see why there is relaxation, why the fabric relax in both waist direction and course directions once you take out the fabric from the machine. So, if you see the fabric on the machine, you apply dead weight at the bottom and you keep running the carrier from left to right and right to left. So, yarn during the knitting are extremely in stress conditions because you are pulling the fabric from the bottom. So, naturally the fabric is under stress condition, each yarn you can see each yarn are being pulled at the bottom side. This is how you apply the dead weight in the fabric and the fabric is under tension condition. So, the moment you take out this fabric and remove the dead weight, you will observe the fabric will try to relax. So, this is relaxation causes the shrinkage in the fabric, and if you carefully see this video, at the knitting zone when the needle is making the loop and when the fabric width is much higher at the knitting zone near the needle, but when you go down you can see the fabric width is reducing. So, you can see here the fabric width is this much, but if you see at the knitting zone the fabric width is more. So, the moment the yarn is moving away from the knitting zone or dead weight zone, you will observe the fabric try to shrink. And why this shrinks? Because naturally you are keeping the yarn under very stress condition. So, the moment you release the stress after taking out the fabric from the machine and removing the dead weight, you will realize the fabric will relax, and during this relaxation fabric shrinks in both length direction and width direction. So, this is called shrinkage of knitted fabric, and shrinkage is very important from garmenting point of view. So, a worker who is standing in front of the machine, he should be knowing how many needles he should select on the machine and how many courses he should run on the machine to achieve certain dimension, meaning certain length and width of the fabric. Fabrics shrink both in coarse direction and Wales direction, and in this lecture we will try to understand why, how much the fabric will shrink, how it relates with the stitches, how the tuck, float and loop controls the shrinkage. Shrinkage, if you see on the machine near the knitting zone, you have selected, let us suppose 20 needles. So, distance between two columns is naturally it should be equals to the machine pitch. If you remember machine pitch definition, it is the distance between two consecutive needles. So, this is the distance between two consecutive needles, which is called machine pitch. So, naturally if you have selected 8 needles on the machine, so the width of the fabric should be 8 times pitch. So, maximum distance between two consecutive wells should be 8 times pitch according to this diagram. But once you take out the fabric, place it on a table, you will realize the fabric will shrink in width direction. So, this is because of stress relaxation in the yarn which is there on the machine. So, this is called relaxation, and we need to see how much the fabric relax both under Wale direction as well as under coarse direction. So, this is important from the sense that whenever we want to create any garment, we need to fix the dimensions, and to create certain dimensions we need to observe how many needles you should select, so that it will give you appropriate amount of width and certain amount of length. So, number of carrier drivers and needles has to be appropriately selected. So, you cannot select these randomly. So, to achieve this, you have to be very clear understanding of how much fabric shrinks once you take out from the machine. So, fabric shrinkage behavior is very much important, and any researchers who is doing knitting and making any garment, he should be aware of that. In relaxation, whenever the moment you take out the fabric from the machine, you can place it on a table, you can go for relaxation. There are two methods through which you can relax the fabric, because the yarn in the fabric are under very high stress conditions. So, you need to give sufficient time to the fabric so that it can relax. So, you can go for dry relaxations, where you can keep the fabric which is produced on the machine immediately on a flat surface and at a room temperature conditions like 24 degrees Celsius and relative humidity 65%, and you can keep the fabric for 24 hours, and you will realize the fabric will keep shrinking, and after 24 hours you will take out the fabric and measure its dimension. So, that will be the actual length and width of the fabric that you will create on the machine. If you go, you can also go for wet relaxation. In most of the companies they follow wet relaxation methods, because this is more close to reality. So, whenever you produce fabric on the machine, you can go and immerse the fabric in the water bath at certain temperature with certain wetting agents. You can keep the fabric under water for 12 hours. After that, you can take out the wet fabric and go for dry relaxation for 24 hours. So, this is done just to make sure the fabric remain stable after multiple use, because if the moment you take out the fabric from the machine and if you make a garment, you will realize the garment size will reduce after some time. So, you will not wanted that, because you always want that the fabric size should be stable, your garment size should be stable, and it should not also shrink even after washing. So, that is why two methods are always followed in companies as well as by researchers. Before doing analysis of any fabric of knitting, you always relax the fabric first and then you go for structural characterization. You cannot immediately measure the loop length or GSM of the fabric just taking the fabric immediately after it is being formed on the machine. So, you always give some time to the knitting fabric for relaxation, because which is very, very important, and it should be done in a very systematic way. I am going to show you some of the basic knit designs, how much they shrinks when I prepare those fabrics from the machines. A small case study, I have few fabric samples also, and how the knit designs actually influence these shrinkage performance. This is the way I created the fabric designs. So, the machine that I used was 14 needles per inch, yarn count was 40 tecks, the machine type was V bed, and after forming the fabric on the machine, I relaxed the fabric using dry relaxation method. I kept the fabric on the table for 24 hours, and some of the designs which I selected just to check the shrinkage performance is 1 cross 1 rib. So, if you remember the rib definitions, double jersey definitions. So, here I was removing 1 needles from the front bed. So, here every alternating needles of front bed is making loops. Similarly, every alternating needles of back bed is making loops. So, that is why this is 1 cross 1. In fabric B, 2 needles of front bed is making and 2 are not in active position. So, 2 on front and 2 on back, they are making loops alternatively. In fabric C, 3 are making loops, then 3 are not making, and 3 on the front and 3 on the back simultaneously. In fabric D, 4 on the front, 4 on the back. So, 4 needles on front side and 4 needles on the back side are left alternatively. So, I created 4 types of fabrics. I also went for 10 cross 10, where 10 on the front side and 10 on the back side, just to check the moment I make all of these fabric designs, how much the fabric shrinks. To observe the shrinkage in course direction, what I did was I used 54.42 centimeter of the machine width on the machine. So, effectively I used 300 needles on the front bed and 300 needles on the back bed. So, the total length on the machine where the fabric was being formed was 54.42, because the machine pitch was 1 by 14. So, you multiply 300 into 1 by 14 and then you convert it into centimeters. So, on the machine I tried to create 54.42 centimeter, but in reality once I make all of these variations, I observe the fabric width reduce significantly. So, you can see here the moment I created the fabric, rib fabric 1 cross 1, after relaxation the fabric width reduces from 54.42 to 33.5. So, 38% relaxation was observed in 1 cross 1 rib. In 2 cross 2 rib, from 54.42 it reaches to 17.025, 68.71%. Then in 3 cross 3, 72% shrinkage was observed, 4 cross 4, 73, 5 cross 5, 76, 10 cross 10, 80.2. So, you can carefully observe this. If you change the fabric design, you will observe different amount of shrinkage. So, you can have the shrinkage from 38% to 80%. So, I have all the fabric sample with me. You can see how much the shrinkage has been happened, although we have used same number of needles for all the fabric samples. Let us see this fabric. So, here you can see I have this fabric samples. So, this is the fabric 3 cross 3. Let's see the difference of 3 cross 3 and 10 cross 10. So, you can see here it is 3 cross 3 fabric and it has been relaxed. So, if you move if you stretch it, you can observe the 3 cross 3. So, if you stretch it, so 3 front loops and then between 2 columns there are 3 back loops. So, this is 3 front loops and then this is 3 back loops, then 3 front loops, then 3 back loops. So, you can see you can stretch very easily. This fabric is highly stretchable, you can see here. So, this fabric is highly stretchable, 3 cross 3. Now, let us go for 10 cross 10, which is even more stretchable. So, if you see 10 cross 10, even a small amount of force you can stretch to almost 400 to 500%. So, here if you try to observe, this is 10 front loops, then this is 10 back loops. So, 10 needles on the front bed, 10 needles on the back bed, then 10 front, 10 back. Okay. So, if you go for 5 cross 5, so if you go for 5 cross 5, again you can see it is highly stretchable fabrics, and if you see 3 cross 3, it is not that, it is also stretchable, but the 10 cross 10 is extremely stretchable with a small force. So, naturally the moment you created this fabric, you can see how much it has shrink, because the nature of fabric is like this. So, all technical back loop is hidden inside. So, between two technical front columns, so this is 10 columns of technical front and this is another 10 columns of technical front. So, between that all 10, so in between all 10 back loops are hidden. So, this is where all 10 back loops are hidden. So, you can see this much amount of technical back loops has shrink the moment I take out from this fabric from the machine. If you go for 3 cross 3, again only 3 needles are hidden here. So, you can, so 3 loops are hidden here, 3 technical, this is technical front 3 columns and then another technical front 3 column, and in between 3 columns of technical back loops are hidden. So, naturally the more number of technical front loops and then technical back loops results in higher shrinkage of the fabrics, which you can see it from the table also. So, if you see 1 cross 1, the shrinkage is 38%, but if you see 10 cross 10, the shrinkage is 80.24. So, naturally with having more and more rib variations, more technical front and back loop alternatively, you can have higher percentage of shrinkage. Shrinkage in wale direction also I observed. So, for wale direction I created 250 courses. So, I created 250 courses consecutively in a sequential form for all the rib variations, and you can see in case of the final length which I observed was 44.075 in 1 cross 1 rib after 250 courses, but for 10 cross 10 the final length was only 34 centimeter even after I created 250 courses. So, naturally the fabric shrinks again in length direction as well for higher number of technical front and technical back loops. So, both in course direction and wales direction, if you have more number of technical front followed by more number of technical back loops, the fabric will try to shrink too much in the course as well as wale direction. Now, let us see the tuck variation. I also created the fabric on the same machine, and this is the rib where all the needles on front bed and back bed was making the fabric, and here only the front bed is making all the fabric, the back bed is in the second course back bed is making tuck, here 2 rib and then followed by 2 tuck. So, the more tuck you can see the shrinkage has been reduced. So, in first case 40% the fabric shrinks, in second case the fabric shrinks by 26.6% and another case 27%. So, having more tuck, naturally the fabric shrinkage will reduced and the final width of the fabric will be more. So, in rib case only rib or loops in the fabric, the relaxed width was 65.1, but with tuck you can see the fabric width was more, and this is obvious. So, if you remember the tuck lecture where I showed you that whenever you introduce tuck, so tuck the legs are open. So, because of that the fabric width will be more. So, if the fabric width is more, it means the fabric is not shrinking too much because of the tuck loop. So, that is why. So, in tuck fabrics you can have higher fabric width. Now, if you see the influence of tuck in wale directions, so in length direction again I created 250 courses. I observed that in case of rib fabrics the fabric length was 39.6 centimeter, but in case of tuck the fabric shrinks. So, 26.3 and here 25.4. So, the fabric shrinks and have much lower length, and the reason because is presence of held loop. So, if you remember whenever you create tuck it is associated with a much bigger loop which is the held loop. So, because of the held loop, the fabric is highly tensioned in length direction or veil direction. So, the moment the fabric is released, that held loop will try to relax, and during that relaxation process you will observe lot of shrinkage in length direction. Okay. So, that is why along the veil direction, whenever held loop is present, fabric will always shrink in length direction. If you see the float variation, so here I created 3 fabric samples, all rib, and here the float in one of the bed. So, first course all rib, in second course front bed is making loop, back is making float, here 2 rib followed by 2 float on the back bed. So, you can see here when along course direction, whenever you are creating float, the shrinkage is not too much. So, 40% shrinkage was observed in rib, 43.3%. So, the shrinkage is limited. So, compared to tuck, where the shrinkage was reduced, but here the shrinkage is more. So, that is why the float results in higher percentage of shrinkage. So, you can also check the dimension of the fabric. So, in relaxed condition the width of the fabric was 65.1 centimeter, but here it is 61.7 and 63.125. So, naturally the fabric has shrink in width direction, which is opposite to the nature of tuck. So, tuck reduces the shrinkage, but float increases the shrinkage in course direction. In veil direction, it follows the similar nature of tuck because of the held loop. So, if you see this the relaxed length along veil direction or length direction. So, for rib it is 39.6, for float variations, these are the 2 float variation fabrics. After 250 courses we observed 30.3 and 26 for these 2 fabrics, while 39.6 for rib fabrics. So, again the argument can be such that it is because of the held loop. So, if you see the back bed here, this needle is making the loop, but next course it is not making loop, it is making float. So, it is still carrying the held loop. So, after third course when you make the fabric, that held loop will be released. So, held loop is always in tension. So, the moment you take out the fabric from the machine, it will try to shrink in length directions. So, much bigger held loop, you can observe much more shrinkage. So, here if you see this needle is holding the loop, but here it is making float. So, this needle is still holding the loop, this needle is again holding the loop, the same old loop. So, the same old loop is hold for 3 courses in this fabric, and here the same needle is holding the held loop for 2 courses. In third courses it is released, here after every 4 course that held loop is released. So, because of that the length of held loop is more in case of floats in this fabric, and the fabric shrinks too much in the veil direction. So, this was obviously the variations of float and tuck designs are unlimited. Naturally, whenever a worker is making any particular machines, or even any students is making any fabric on a particular machine, you need to be very careful what designs you are making. You need to first make lot of trials, fabric samples, and observe the behavior, and then you can set the machine in a particular sequence. So, once in reality whenever a particular machine is making certain dimensions of the fabric in V-bed, that machine is left unchanged until unless if new design has to be created. So, either the float will remain same or the tuck sequence will remain same, because the moment you change any of the sequence, the fabric dimensions will be different. So, in reality this is just the influence. So, shrinkage along course, you can observe more and more technical front loops followed by technical back loops results in higher shrinkage of the fabric in course direction. If you have more tuck stitches in a course, it will reduce the fabric shrinkage and you can expect the fabric width is more. In case of float, you will observe little bit shrinkage along course direction, but not that much significant. But naturally when you have tuck and float stitches in a course, it will result in fabric shrinkage along length direction. So, both tuck and float has its own influence on the structure. Also the technical front and back loops in a course has its own influence on the structure. So, you better be careful whenever you design any fabric and want to create a certain dimensions. I thought maybe this topic is heavily ignored in literatures, but whenever you go for design, you should keep all of these things in the mind whenever you are dealing with any kind of weft knitted samples. So, with this I am stopping with this lecture. In the next few lectures I am going to again following some of the important properties, especially the extensibility and the recovery aspects of knitted fabric, which is also very important from design point of view. So, once again thank you very much.